So the last video cut me off. It was able to play it, but you can't skip it. So just, you do the entire thing. Can't skip it. I'll put that in the description, but you guys probably already know since you guys are here. But quickly, we stopped here, and this one was all good, right? It equals 1, so check. This is a good one, right, when it comes to it. And then finally is D. So the number of classes a student passed for the current semester if the student took 4 classes. So first off, if you add them, you should give you 1, so check on that. Next, they're all between 0 and 1, so that's good. So everything looks good except for one little thing. So this student took 4 classes, and this says the number of students passed. Well, technically, right, you can pass all 4, or you can pass none of them. So it's actually missing 0. So this is not valid because of that. Okay. So that was the last question. So I hope you guys got them all correct when it comes to it. Now, what we're going to care about the most is how do you actually create one? That's the most important thing we want to care about. This one that's going to be question 1 here. So at the very bottom, right? So here's a probability distribution for an imaginary horse race. The first row lists the values of the horse, and the second row gives the probability of the corresponding value in the first row. So basically, this is the probability of horse A winning and so forth down the line. So the question is, first one is complete the table for finding the probability of horse B to win. So I'll give you guys a quick minute to try that. So pause it and try it. Okay. So remember, right? One of the major things is they all have to equal 1, right? The whole sum must equal 1 to be true. So therefore, right, if we just pick this to be x and just solve backwards. So if we just solve backwards going from there, we can find what what's b have to be. So it should give you 0.22 for b, right? So that's the probability of b, because now we know that very special case, they all equal 1. So we can, if you're missing 1, you can now find it itself. So now using this portion, now just go ahead and quickly do the rest of them. B, C from that portion. So again, pause it. 3, 2, 1, go. Okay. All right. So what is more likely to win, a horse B or horse F? Well, going back to what we have, right? Horse B was 0.22. Horse F is 0.08. So therefore, since this is more probability, right, horse B for sure, right? So you may want to put your bets on horse B instead. Now, next one, just little fun ones you guys remember from the exam, right? Probabilities, ors and stuff. So find each one. So probably A or win maybe. Sorry, a probability of A wins or B wins. So or is addition. So we're just gonna add them together, right? So probably A winning is 0.28 plus 0.22 should give us 0.5, right? 50%. And the last one is probably of not F wins. So if F doesn't win, that means the probability of everybody else wins, right? So not this one. So it's basically 1 minus, or the sum of everything else, should give you 0.92. All right. So now for question 2, now we're actually going to construct it from a little bit of scratch, not too much, but in basically this portion. So first off is question 2 says, consider the variable blood type. This is a categorical variable with variables values of A, B, and O, right? Those are the blood types we have in our human system. The table gives the frequencies for the large sample of a random chosen individuals. To complete the probability distribution, use the relative frequency. Oh, that's interesting, right? This is from your exam. Relative frequency to estimate the probability of randomly choosing a person with a given blood type. All right, so we've actually already know how to do a probability distribution. So this is a frequency distribution. We want is a probability distribution. Now, believe it or not, it is literally the same thing as just finding the relative frequency. That's it. Just find relative frequency. Okay. Meaning, right, going back to your first question in the exam, you're going to add all the frequencies up and divide every one of these by the total. So I'll give you guys a quick minute to just do that. So you can just pause it. 3, 2, 1, go for it. Okay. All right. So let's get the answer now. So it should be a total of 5,500. So if you divide every single one by 5,500, GV 0.45, 0.41, 0.1, and then finally 0.04. That's it. So that's the, one of the steps, right? So it's not completely from scratch, but it's partially, right, when it comes to those. Given a frequency, now you construct a probability distribution just by using the relative frequency. Believe it or not. Crazy, huh? So that's the first part. So next, let's talk about something called a random variable. So a random variable is a numerical measure of the outcome of an experiment, i.e., it is a quantitative variable. So quantitative means numerical, mean number itself. So it gives you out a number. Okay. Random variables are typically denoted with capital letters near the end of the alphabet, such as X or Y. So hence why it's called probability of X, right? Because you use X in general. So question 3 says, is basically, given these 3 scenarios, A, B, and C, can you see, does that scenario give you a random variable or not? So again, go quickly, just pause it real quick and try these out. So is this a random variable based on the definition itself? A, B, and C. So 3, 2, 1, go for it. Okay, so hopefully you guys tried them. So A says, suppose we randomly select a person and test their blood type. Is the variable blood type a random variable? Well, remember, blood type gives you what? Does that give you a number out or something else? So blood type tells you, right, going back over here, it gives you a letter out, which is not a numerical value. So this is a hard no because of that. So not a random variable because doesn't give you a number out. Okay. B says, suppose we toss a coin 4 times. Is the variable number of heads a random variable? So if you toss it and you say, how many heads you get, would you tell me a letter or an actual number? And you give me a number, right? So this is a yes when it comes to it. So that is a numerical because it gives you a number out. So now C says, yes, still tossing a coin 3 times. List all possible values for the random variable X equaling number of heads. So this is what I mean by you're actually going to start from scratch. So X is how many heads I can get out by tossing 3 coins. So let's just start with the first, right? I can get 1 coin, 2 coins, or all 3 of them as well. And is that it? Well, hopefully you say no, right? Because technically I can get no heads. That means all tails. So that's all of the X values associated with getting a heads, right? I can get all 3 heads, 2 of them, 1 of them, or none of them. So that's what I mean by actually, writing out the X variables themselves. Okay. All right. So then after that, we now go into the main concept here. Actually constructed it from scratch. Okay. So I'm going to end it here for this video just in case it breaks down or just freezes on me. So here's the second part of the lecture.